Um, so do you have a plan?
I want to talk about migrations. Like,
Okay. Before we talk
like
about that,
get
I want to talk about the PR.
Mhm.
Um, I read it and I think it's looking pretty good.
Mhm.
I could probably just R plus it. The only thing that I thought was the set of tests in the PR looked a little meager, and I
Um,
couldn't remember if there's a bunch more tests that I kind of forgot about, like that maybe I did in
so
some
there,
previous
there are a
PR.
couple of tests that are not in here. For well, there are a couple of things I want to test, but I'll slowly add those tests once we fix them because what I'd initially done was I added them. They just don't work because patterns or mutability issues are
Okay.
those. So those will be. I want to add them as I fix them so that it's like if someone looks at a PR, like in the
Yeah, yeah.
future, they see why
Okay.
they're relevant.
All right. I
I'll add it.
I think I'd be happy to R plus. I was trying to think. I feel like there's a lot of corner cases around things like finding the minimum ancestor and stuff like that, which are not really being exercised by the tests that are
Uh,
there though, like
okay.
accessing life patterns and stuff like that. But I guess those were tested by the earlier PR,
Yeah,
which then had
yeah.
the okay.
Like the precision. So we did that. There's one test that does this. What I'll do is I'll add a couple bottle checker tests here because we still see them failing because like we now see precise bottle checker errors regardless of us fixing things, which is
Sure.
nice.
I
So
still
that's
think
some of
it'd be
those.
nice. The one I guess I still think it'd be nice to have some run past tests that just exercise uh
Min
like
capture.
exercise not necessarily min capture, but places that are more complex than just A.B, like for example, indexes or stars of box, stuff like that.
Okay, I'll add some of those. Yeah, I have tests for them. Though those weren't really okay, so
I mean, they should work,
yeah,
right? Like the same
yeah, it
basic
should work.
patterns that you have, but with a more
So what I've done is like I guess we should add test case exclusively, but yeah, well explicitly. I did make the whole test the whole compiler compiles as a thing. So
you
I
did do
think
that. You're saying, or
yes, I did do that. So and we can go with the perf as well
yeah, I
if
mean,
you
I feel
want.
pretty good about it. I would like to
Nah,
make sure we're
no, no, it
exercising.
makes sense.
Oh.
Yeah, I think I was doing the compiler where I found out that the migration issue might be.
And the current status after this PR is basically it works, except for a bunch of small bugs.
Uh, yes, categorically speaking, three main issues. One is when we have mutable references.
Uh-huh.
Then we have moves. And the third one would be unsafe pointers.
And the moves, we had talked about modifying moves to only move interior paths.
Yes, drop any derefs or any projections after, and well, of course, any projections after that.
And
That's what.
that's not implemented though.
That's I have commits for them. I have tested them because I needed to do that for the whole compiler when I was doing the whole compiler test.
But they're not in this.
But they're not in this PR just because they're small patches.
No, I think that's good. I still am not sure if that's the right rule. I think
Uh,
we might need to go with the like dumbest rule of move just means capture all the local variables. But that was something
so
I wanted to bring up. I was thinking we should schedule a Lang team design meeting to talk us
yeah.
over.
Hmm.
Probably not till the new year, I guess,
Hmm.
given the
Yeah,
calendar.
that's fair.
I don't know whether you all are available at our usual slot. It's on Wednesdays at 1 p.m. Eastern time.
I will be available. Well, not next week. Next week is last week of my
No,
internship, so
think
I'm not gonna
January.
do that. But
Don't think December.
after that, after next week, I'm free. But I'm assuming everyone's gone for holidays, so
Yeah, I think it would be like January
e
15th or something like that.
yeah, that's
13th.
fine. Yeah, we our winter break is still like January 11th this time, so we have a lot of time to kind of prototype things and like test things out.
I'll ping you
Uh,
all on Zoom.
yeah,
I have to schedule it anyway. Uh, but this is gonna be a bit of a judgment call.
yeah.
Um, Either way, let's talk about migrations because it's going to be relevant.
I was gonna discuss some, yeah, so one thing that was brought up during the RFC was, and I'll send a link again here. It's similar to what we were discussing last time, and I think it's maybe written a bit more formally. It's on the Zoom chat. So was essentially that we add, from what I see is basically instead of removing a deref, what we see is that if our base type was an reference, we add a borrow to it, is kind of how I'm picturing this.
What am I reading here? The RFC is about how captures is split up, so the closure group, blah, blah, blah. So
At least the way I understand this is we essentially enforce. So let's say we had a mutable reference or something, let's say some point, and we capture star p.x. And instead of, since p, our base type was the reference itself, we essentially add a borrow on top of this and then move the borrow instead of moving star p.x, which is a value.
yeah, so this what Sam Sartor wrote here, we had a hackmd last time, right?
Yes, we did. It's on the GitHub issue. Yeah.
Where is it? This must be it. It doesn't have a very good title.
Which one was move out of references? And okay, I think I should probably make it better. But I can.
Yeah, it's called. Well, if I'm opening the right one, it says like issue 31 at the top.
Yes, it is issue 31.
Okay, so let's see. I don't know, whatever. So you have it open?
I have it open, yes.
Right. So I think this rule that Sam describes is the same one that I arrived at.
Yeah.
But where I wrote possible extension on.
I thought this was more around the option one we were looking at maybe, but yeah, possible extension, yes.
Sometimes capture by reference. Oh, I guess I'll share this. Why not?
Maybe have it running.
Okay. So this extension here, I think that that's exactly what he's saying is exactly what I proposed there.
Yes, I'm trying to see where the complex lifetime interaction is coming from, because earlier, again, we are moving earlier we would have moved a reference. We are still kind of moving a.
Actually, this is interesting because it's connected to the new match, the match modes change that we recently introduced a few years back. Not sure if you're familiar with that.
I am not. Is it the ergonomics one?
Yeah, I mean, like if you do this today, or well, you can't do that, but bother.
Some ampersand. Okay. Yeah.
So we wind up turning this into a reference because you kind of pass through this reference.
Oh, I see.
And that's what we call a borrowing mode. And that's kind of the same rule. I hadn't actually seen that until I read what Sam wrote there. That's a good, he didn't explicitly make this connection, but the idea is the same. That sort of, when you capture something that's borrowed, you're capturing a borrow of that. We're propagating that.
Yeah. Yeah, exactly.
I think that is probably the rule we want. It is not this truncate on deref rule.
Yes, I think so.
It's an extension of it, which is why I wrote extension. Like it sometimes, basically, we would still truncate a deref, but only for boxes, or like, but not for reference derefs. We would truncate derefs that are of other things, which in this case,
Yeah, so that's what I was thinking. Like again, in the RFC, it was discussed that we probably want to special case box. And what I was thinking over the last week was maybe we should not use box as our motivation to do some of these things, but rather handle box as a thing of its own. I do not know what the complexity around that would be.
so the problem is, I still feel like I don't know. I think we should defer this question. This seems to me
Okay.
to be a policy question, and we should take it to the Lang team.
Mhm,
And it would be useful, and I can try to do that,
mhm,
to write up the like options and
mhm.
interesting cases. I think I have a pretty good handle on that, and I can
Okay.
try to write up the things. But in the end of the day, this is a policy question of like
Mhm,
what policy, right? It's not an
mhm.
implementation problem. It's a problem of
Yeah,
what is the right thing for the language.
what's the right thing to do?
Yeah.
I sent a doc last week where I just kind of documented some of them with examples. If you want to use
Yeah.
that,
Is it linked
yeah,
somewhere?
it's on the Zulip. I sent it in the status meeting from last week. I'll send it again here.
It'd be great to dump it in this document.
All right, I'll link it here, and I can just add it on Zulip as well as the 2020 status.
Great.
Sorry, not on Zulip, on GitHub.
Oh, okay. That's fine. What I would like to do is talk about implementing the migrations.
Yes.
One thing I will note is that these rules are all about move closures. Like, we have to consider move and not move closures.
Mhm.
And I don't know whether they should behave the same or not. But
Uh,
like, I have opinion. That's something we're gonna have to decide.
mhm.
However, non-move closures, in my opinion, like, what am I saying? Uh,
So,
they, I think there may be room for them to be like, what am I saying? Whatever they do, I think they'll probably want to be at least this precise. This is what I'm trying to say. So
ye-
you don't want it to be that you move A.B.C and you capture A. That's like too strong. I think you just want to capture
yeah,
A.B.
yeah. So my concern comes around that moves behave differently in a move closure versus in a regular closure, and I understand that it's because of, well, the move keyword. I do not know if that will add to any confusion.
That's the policy we have to decide.
Yeah.
But I guess the point is that like we should think about, all I'm trying to say is there will probably be some subset of cases where moves occur
Mhm.
differently than they used to. And that might be for all closures, or it might be for only like non-move closures. But either way, we need migration. That's
Yes,
what
we
I'm
do.
saying. So we can try to
Yeah.
implement the migration and then decide how often we have to use it separately.
Mhm. So,
So, okay. 'Cause, yeah, so the question is how to implement it, right? Or
mhm.
what? Or did you have other questions about migration?
I did not. I just had concerns about the issues that we discussed, but again, that's a policy thing as we discussed. So,
Yeah. Why don't we talk a little bit about it? I'm gonna make. I don't know whether to just dump it into this HackMD or maybe I'll make a fresh one.
uh, we have a couple issues of migrations. We can drop the hack company in one of those. I'll link it to my 2020 status doc.
Okay.
Or if you want to just write it in there, I'll send the link again here. There's to be decided section for migrations anyway. So,
Where are you sending what?
Zoom chat.
Great.
So there's the
I see. Yeah, great. Migration plan. This is cool. Okay. So open. No, I'm trying to find. Why can't I find this right now? There, migration plan. Okay. So. So.
Also, do you want to share your? Oh, it probably is getting.
Yeah, let me share. That makes sense. So what I would say is, in some cases, the closures will capture different paths or different places than they did before, right? And this affects the runtime semantics because, or actually what they will do is not just different, but narrower places than they did before, right? More precise. Narrower sounds funny. I don't know why. It affects the runtime semantics because the destructor for the, or because the destructors can run at different times. In the older version, the destructor for the base variable x would run when the closure was dropped because the closure owned x. In the newer version, if the closure only captures x dot y, and the destructor for y will run when the closure is dropped, or for the field y. But the destructor for the remainder of x will run in the creator's scope. Right? Does this all make sense?
Yep.
Okay, so workaround is introduce let x equals x into the closure. And now I can make an observation, a few observations. This only matters if there is a, or let me start with this. Not all destructors matter, or let's put it this way, let me rephrase it. Few destructors actually have side effects in practice. Most just free memory. Most users don't really care when the destructor runs as long as it runs. And or they would probably prefer the memory to be freed earlier, which I don't know.
Results.
Which it may be, or may not be, with the more precise capture. The reason I say that is if you make a move closure and you return it from your stack frame,
yeah, when it gets freed,
it's living longer than your stack frame. So that, but on the other hand, if the closure does not escape the stack frame, then that's not true. But in that case, it's probably not. Anyway, the point is, my hypothesis is so long as the destructors are only freeing memory, we don't care. And I think we would be doing users a disservice if we migrate their code such that, if we introduce let x equals x just because some string might get freed at a slightly different time, that's my consensus. So long as the destructors only free memory, we probably, or we should not try to preserve their ordering, their precise ordering through automated migration. We could have an opt-in, maybe. I don't know. We don't have any mechanism for that right now, and that's fine. I wouldn't worry about it. It's just a really easy thing. So what I basically want to do is, how I think it should work is we should detect if the no longer moved content has a type that may have a sort of significant destructor.
Mhm.
And how do you define what a significant destructor? Well, probably what I would do is annotate destructors in the standard library with some crazy attribute,
Oh,
and everything else is significant. So we essentially have an accept list
mhm.
or something. And the point being now, then we have to sort of walk the type of each path, of each non-captured place or no longer captured, and see whether it may include a T2. That makes sense so far?
Kind of. Yeah, that's just technically we just recurse through it. Yeah, that makes sense. It would be interesting to see. Wait, are we allowed to put attributes on standard lib definitions?
Yes.
Isn't that okay?
The standard lib is tied to the version of the
RFC?
compiler that is building it, basically.
Okay.
So you can have like nightly unstable things in there. That's kind of
Okay.
what makes standard lib special. It's the
Okay.
only piece of Rust code that can ship unstable things in stable.
All right.
But we have to be very careful to, not
Yeah.
expect. And yeah, we'll have to write a little bit of logic to like say, like if you have a tuple, whatever. It has to know. There kind of is code for doing this already. It'll have to be slightly adapted. There's code for figuring out if we need to run a destructor at all.
Mhm.
We would have
Yes.
to like tweak it with a Boolean or some kind of flag that says like,
If significant or something.
yeah, and there's a little bit of other logic we're going to need to like say, here's the place that is now captured, so don't walk the types that come from those fields.
Yeah, that's going to be.
It's going to be interesting.
Yeah, that's going to be an interesting. Oh, yeah. So this would also need to be done after type check because that's when we figure out what's being captured.
Yeah, this can happen like whenever, right?
Okay.
So it can be pretty late. And actually, it wants to run in the old edition. So it's going to want to run. This is kind of a nice thing, or it's good that you have the code, which is computing. We're going to need to know what the precise paths are.
Yes, we can do that.
Even in the old edition, like even when the feature is turned off.
We can fake it.
Yeah, I figure we can because if I remember, you're doing the analysis now, and then you're like adding some moves later, right? Or something to
Sorry.
force it to go to the.
Well, we just fake it's not fake really. We just initialize reads for the upwards mentioned that were mentioned, and that will just force the min capture to do things.
But you do that at the end, right?
We do that at the start right now because we realize there's no reason to move it to the end. But yes, well, not until recently, but yeah, we'll probably move it to the end.
Yeah.
So
Now
the
we
reason
have.
we want to move it to the end is because that allows us to prioritize the things we see inside than just whatever fake things we created earlier. And in the
Yeah.
sense that our algorithm prioritizes what we see earlier over things we see later. And it just forces any kind of fake information that we are adding into there to be as less of as little priority as possible.
I sort of remembered that, but I think this is a second reason then to do it at the end because we're going to need to be able to diff what would be the most precise path with what actually got captured. And
Mhm.
so,
Okay. Yeah.
so you'll have to save it off or something, but right. So we'll do that. And then,
I'm assuming there's some kind of like context, right, that we are doing this particular analysis. Like we're doing this migration analysis or whatever we want to call this.
yeah,
So
it can just run at the end of upvar analysis, right?
like capture analysis, not upper analysis.
Uh,
Actually, no, we don't really need that. Yes, you're right. I can just take so what would be have been previously captured to what is now being captured is essentially upwards mentioned was being what is was being really captured before, and this is what is being captured now. The
yeah,
only question comes down to is do we need I'm forgetting. Yeah, the moves is what we really care about. So we might need to figure out which paths would have been moved
yeah.
really.
You
So
know that by the end of type check, essentially.
yes, but what I was thinking was using upwards mentioned directly to figure it out. But yeah, this is possible to do something of this sort. It
Yeah.
should work.
I think we're gonna wait. I think you have to do it at the end of upvar.rs, essentially.
In check, yes, yes. So there's two analyses, right? One is when you subpar analysis, it confuses me for like the very first pass that happens for things that are just mentioned. And when I say capture analysis, like the second one, which is the type check one.
No, yeah, we need it after capture analysis. And it, I think what it's gonna want to do is something like if you're doing the analysis, then you save the value of the captures, you make a clone
Yeah.
before before you add in the
And then
read.
you just min capture all over again. And then it will just
Well,
fix things up.
then you add in the fake reads of all the mentioned upvars, and then you have the two versions, right? Because you have the one you cloned from before, and then you have the one that's been modified.
When you add it, you need to run min capture again, but yes, that will work.
Okay, right.
Yeah.
Yeah, and yeah, so then and the point is it will be like zero cost if, or what's nice about this is you're going to do the clone sort of into a local variable
Hmm.
during the upvar analysis.
Hmm.
And that means you'll drop that local variable when it's done. So we won't like expand the memory usage and so forth.
Hmm.
In particular, it never has to get stored into any query result.
Yeah.
Um,
Sorry.
clone the captured variable data before adding in the fake reads of mentioned upvars and sort of add fake reads of mentioned upvars. We run capture analysis. Now we can diff the results. And I think a good place to start, I guess, is like this is a plenty of challenge to get all this working. But once we do have it working, we will have a list of local variables that may contain a significant. We could do this we can do this the approximated way.
Okay. What do you mean by the approximated way here?
So there's basically an analysis that we want to run that's like
Mhm.
it's like given uh, uh, given the captured place, given the minimum captured place,
Mhm.
it returns.
Mhm.
I guess it only needs the minimum captured place because we always used to capture the whole variable.
Mhm.
Returns true if um, the local variable may have a significant destructor in its type, and that destructor is not or is found somewhere outside the captured place.
Mhm.
And my point is this second part is optional because that's like more precise. But if I had to take a guess, I would guess that most of the time it won't matter. So, and
Okay, quite. Sorry, go ahead.
I'll give you an example of what I think it's probably worth writing a few examples to show what I'm talking about, unless you're completely following and don't think that's necessary.
Examples would be nice, but I do think I'm following you.
Okay, well, here's an example anyway, just because. So, you might have some code like this, and this is an example of changes semantics, but who cares? And the change in semantics is like x is dropped, sorry, x dot 1 is dropped
later.
when the block exits, not when C is dropped. Yeah, just slightly later, or the ordering is changing. And if we change this to, so this case, this is actually kind of the same, because who cares? Because the thing that's changed is a string.
Yes, you're right.
And this
But if
case,
you were to drop x.1,
this is different, right?
Yeah, all right, that works. Sure.
Yeah. But what I'm basically arguing, and what I'm basically arguing is maybe this case, this is the optional case. So I'm saying that if we make the analysis simpler, all we would do is say, does X anywhere have a significant destructor, yes or no?
Yeah, no.
If the answer is yes, then we'll conservatively transform it, even if because we happen to capture the significant destructor, it doesn't actually matter. And then we could go back later and make it better.
So that's where my question was coming from, is like when we do this type analysis sort of thing, how do we figure out, how do we plan on storing the path itself, that where the, like, I know it's optional, but if we were to do that, how do we store that? Oh, if the path that we take is, let's say this was something complicated, again, a dot b dot c, and we had again an a dot b dot d. How do we store that? A dot b dot d would.
Yeah, we'd have to write some code. I don't know where. I'm trying to find the best thing to.
Like the way my head was around this was like, if we can get a list of all significant drop paths and we can represent it similar to places, we can again do the similar ancestor analysis sort of thing we do for min capture, and that will give us.
Yeah, that would be one way. It's probably not the way I would do it, but it would be one way. I think, needs drop, I think is what this code is called. So we have some code called needs drop. This does not do what we want, but what this does is this figures out, so needs drop figures out in an approximated way if any part of this type may define a destructor, basically. But it only considers the type. So what I would probably do if I were going to write this code is make a variant of needs drop that takes the place as argument, takes an optional place, and it kind of matches up the projection. So it would be like, okay, the place is the place of the sort of the local variable or whatever. And it would say, okay, the first projection is the field F. That means the local variable better be a struct, because you can't field from a non-struct. And if you look at how needs drop is implemented, what you'll see is it basically says, well, okay, it calls needs drop component, wherever that is. But basically it matches the type. And let's say it's okay, this is annoying, but the code is like kind of generic and weird. But the point is, this is a good example. For tuples, it goes through each of the fields
Mhm.
calls needs drop on the tuples.
Yeah.
And so what I'm imagining is you would look at the place and you would say, this is the .1 field. I'll go through all the fields that are not .1 and
Mhm.
put them into this vector. And .1, I'm just going to ignore it because, well,
Okay, that makes sense.
that's actually not quite right. You have to get to the end of the place before you can actually ignore it. But what you would do is you would have this optional place that's like, if you match this place, or maybe it's an optional slice of projections, actually. If this slice is empty, then you found a match. So you can just stop here because that's the place that got captured, so I can ignore it.
Okay.
If this place is none, then I always do all the work because that's some part that I didn't capture. And if the slice is non-empty, then I like pop off the prefix when I find that part, and otherwise I pass none. Does that make sense?
I mean, sort of like I get the general idea. I think when I start writing code, it will just kind of make sense. Also, like we really just care about ADTs and tuples here because that's what introduced our field projections.
Right.
And I don't know what's happening with DREFs in this situation, but again, it's just like it will provide us access to another field at best.
DREFs are actually the easiest case, right? Because there's no, like, there's only one. It's like a field. There's only one of them, so it's always a match.
Yeah, exactly. Yeah.
Yeah, so that's how I would do it. I would probably not do that to start because I think that's a beautiful follow-up PR, and it's not the hard part. We haven't gotten to the hard part yet. I would start just by using needs drop.
Okay.
Or a variant of needs drop, which we'll have to define. That, I mean, honestly, we could actually just start with needs drop.
Yeah, I think needs drop is
the
good
right
enough.
And not even have the idea of significant destructors because we can test all the hard code with local copy types. Yeah, so then make needs drop understand significant destructors, and then these are like the refinements we can do. Now the hard part is this one. We come to some list of local variables that used to be captured, and we want to have backwards compatibility around them. Or, and I'm just going to say, and they may have significant detours, which we can define what significant means in more and more refined ways. So then this is where we have to make a suggestion to modify the text of the closure in some way. And one thing I will say that's relevant here is if, I guess it depends what comes out of that Lang team meeting, because if what we decide is that move closures need we need some more complex syntax for people so they can more conveniently handle some of these annoying cases, that may affect what we do here. Because right now, the only workaround we have is let x equals x inserted into the body, which is okay, but it's kind of annoying. We have to, if the closure doesn't have a block already, we have to add
fair point.
X kind of at the front and at the end, else. And the nice thing is we can make these edits really gross. Like the formatting doesn't have to be good. It just has to tokenize so that Rust format can run. But it's still gross. Like whatever we do, it's going to be grody, hacky code that sort of says.
I mean,
it's not the end of the world, but it could definitely work. However, imagine that we added a syntax like move. No. Like suppose you could write this. I don't know. Which kind of says, I want to move these two paths.
Kind of like the C++ way of doing that.
Yeah. I don't really know what this syntax looks like, but let's imagine that it was something like that. This would be an easier transition for us to make. Like if we have that syntax, we should use it.
that actually is way better than what I was suggesting. And yes,
I kind of suspect the outcome of this meeting may be that we want some syntax like that. Like it's been kicked around for a long time that
Mm,
there's kind of no, when we designed closures,
mhm.
because of the way my brain works, I thought it's perfectly acceptable to have the like capture clause be written in this form.
Oh,
Like make a block that has a bunch of lets and then a move that just uses those lets, and that's like a capture clause. Not really, right? But it
ag-
has the effect
again,
given
this
it.
is very close to C++. Like
Yeah.
it's,
So the point
yeah.
is, all I mean is that the the move closures are fully general
Mhm.
in the sense that they can express any possible captures you might want to do if you use this sort of
Yeah,
form.
exactly.
But nobody in their right mind thinks of this except for me. you know,
I
uh,
Yeah, I think this was just like workarounds that I read on the RFC. Yeah. So
right. And another one that's very common that I've seen people complain about is this.
uh,
This is
yeah.
this is something I do all the time, but like I said, I've shown it to a few people and they were like, well, I never thought of that. So the point
Mhm,
being, we're actually missing a syntax here, and maybe we need to answer this problem. And
mhm,
maybe that will give us a better transition.
mhm,
Unfortunately, designing that syntax is like non-trivial.
mhm,
A lot of interesting questions about it. Well, not impossible. I don't know. We can do it.
mhm.
So
I
I,
guess still comes down to where do we insert this text, right?
yeah, it's not going to be that much different for you in the end of the day. They're both going to be textual edits. The only difference is
Y-
in this version,
I guess my question was more around where in this code we force this actual edit to happen on the user's code.
oh, sorry, yeah, so what you would do is you would, once you have this list, and let's assume we can generate the edits in some reasonable way,
Hmm.
you make a lint,
Hmm.
and that lint carries a suggestion.
Oh, and cargo fix it.
That's right.
All
That's
right.
how we do migrations. We issue lints, and people run cargo fix to move between. Um,
Uh,
to, we have like
okay.
cargo fix dash dash addition or something.
Okay. All
So
right.
it's
So
not
I
your
guess the
job to
first
actually
problem comes.
your job is
Sorry.
to. I'm saying it's not your job to actually apply the edit. Your job is only
Okay.
to
Yeah.
make a suggestion. Uh,
Okay. That is. All right. Okay. That is overall nicer.
yes.
Yeah. Okay. So I guess yeah, the challenge for next come weeks for us is just getting this as clean as possible while we get whatever open PRs are in before break hits.
Yeah.
When
I
is the
actually think this. I will say that this let x equals x is probably not that hard. We'll
yeah.
see. It's a little grody, but it's not as bad as I first thought it was going to be. Because I think
Mhm.
at first I thought it was going to require the ones I really hate are the ones that like read the text the user wrote and try to like reparse it a little bit to figure out what to do.
Oh,
And that's
okay.
terrible. But this won't have
No,
to
I
do.
think we have a lot of information already. So,
But really, like, there's plenty of code to write just to get to the point where you're ready to make the edit in the first place. Like a good first PR, I think, would add the lint just
mhm,
using name drop, not any of the smarter versions, but without a
mhm.
suggestion. So just start giving warnings where the semantics might have changed.
Okay, yeah, that
And then you
makes
can come
sense.
back and add the suggestion, and then we can make the suggestion and then we can refine, or we can independently add suggestions and make the lint more targeted.
Like,
Um,
mhm, that makes sense. Yeah.
and it could potentially all go in one PR too, but that's how I would implement it at least.
Hmm. I think separate would be easier to get quicker review process.
Also true. Yeah. I will definitely, to the extent that I will work over the break, like I said, I would love to help you all. I don't want you to block. But
Mhm.
yeah, small PRs, like I'll have smaller bursts of time, so small PRs will be much
Yeah,
easier.
yeah, no, that makes sense. Uh, yeah, okay, so I have somewhat of an idea here. I think that's good enough to kick things off. Yeah, another issue that I missed was like our issue around patterns and I don't know if you like that. It's extendable to like the functional update pattern as well. So if you scroll up a little, or if you go on the view thing, like the third option, hack MD as, and then there's the open bugs and migrations, and then there's the first one. Uh, yeah, so we have patterns. So we don't have destructured patterns just don't work at all right now, and that is mostly because we expect like we have workaround for this, so this is not too big a concern. But at some point, I think this would be. We have how much time do we have? Oh, we have 12 minutes, so maybe we can just discuss this a bit more detail because it's patterns, and then there's also the struct update syntax, which is like the point two in this that also doesn't work for the exact same reason. Which is the place is completely mentioned but only partially captured. And if it is partially sorry, I actually, okay, yeah. So if it's partially captured, also, wait, are you, I feel like, okay, never mind. My
Sorry, I was
headphones did a
scrolling
weird
up
thing.
and down while I listened, but
No, sorry, I got a call and then, give me 1 second, sorry.
yeah, go ahead.
Yeah, I
You
got
brought
a
it up.
call. Yeah, so essentially the pro issue is the same thing. We have a place that's completely mentioned that's mentioned in the in our code within our closure, but it's the way we capture it does not express it
Yeah.
as completely captured.
Yep.
So,
So,
and this extends outside of just patterns.
right. I mean, we've talked a lot about these cases, and that was sort of part of the motivation for the whole place builder
Mhm.
refactoring. Um, is there
I'm
something new there, or is it that in terms of patterns, or is it that we just haven't tried yet to?
I haven't tried it. We haven't tried this yet, and I'm just want to discuss that. We'll probably just have to do this across more in, I think, like across the whole build at this. I don't know if it needs to be across build or not, is I guess my concern, or because now we have this functional syntax one as well.
Well, there's this
But
case. There's only two cases.
yes, yes. So
I don't know what
that's
this one.
this is the one where I don't think this
Oh,
is entire.
right,
This
right.
is a separate issue.
This is a separate issue.
That's a separate issue.
Um, I think this is probably relatively easy for us to fix. Uh,
The okay.
there's an analysis that takes place in writeback to
Mhm.
figure out,
Yeah, yeah,
and I don't see any reason we can't sort of move that code earlier.
yeah. Okay.
It just didn't have a reason before. But like all the types are known, that's all we really need.
Yeah. So for the mentioned one, we just basically replace most things in place build in mer build to just use place builder, or do we still be no, well, the ones above. Do we still be a little bit more conservative about it?
I would ignore these for now.
Okay.
I
And
think
do you,
they're like just refactorings from my
yeah,
view.
okay.
I don't have any fears that we'll run into surprising problems.
Okay. And would you want me to submit a workaround PR for this so that it would be nice if people, if there are weird cases that people can, there are other people that can think of when they use this. So I'm wondering if we should have, uh,
What is a workaround PR?
like, should I create a workaround PR? I just created a commit when I was trying to get the compiler to build with this feature. So
I don't know what
I'll,
a workaround PR means.
by that, I just mean, well, a PR that has the workaround where we, if you look at the commit, we essentially,
Oh, oh, you mean like edits to RFC that work around this problem?
yes. And I can like, this is the
I see.
general solution. I can just add functions which are actually just named fake consume for 2229. The first one isn't really relevant. It's just the second file that's
I
relevant.
would land this PR, yes. Only I like the idea of naming them like fix me PR, fake consume.
Okay.
I think that's
Yeah.
good.
Yeah.
I would add that for now and file an issue to resolve it some future
Okay.
time.
All right.
I am much more worried about this.
Yeah.
This- But
Again, this comes down to the migration issue. Like if
I
we
know
just add,
this is a case of migration that isn't covered by what we talked about.
this would be, or should be, from what I
Oh, well, this
understand.
would be because, well,
Like
no,
if we had a,
I mean, this would be because this would not be,
oh, because of drop. Yes, it won't work because of our drop
well,
conditions.
this exact example probably would work because we don't know what the drop, or we could probably make a assert unwind unsafe in some way be considered a significant destructor.
So
You know?
if you go in the issues again, I think issue 29. Issue 29, not 28.
Oh, sorry.
Yeah. And there was like another example that I put up there. Like scroll to the bottom where we for send and sync.
Yeah.
So people might want to wrap things.
Right. I mean, I think we can probably make, right, we can potentially make some of these examples work, but the general case worries me because it's easy enough for someone to write their own
Code or
pattern
something.
that has a
Yeah.
similar problem. And there's no way we're going to migrate like if any trait is implemented by, like we can't tell that question.
Yeah,
right?
exactly.
So we plausibly we could figure out something.
Mm-hmm.
No, I don't know. I don't.
Yeah.
I don't really want to get it. If the migration needs us to be like super smart, smarter than it's already pretty smart. If it has to get smarter than what I've already described, I'm worried. So this is part of the reason that I feel like there's a case for move capturing local variables only. I still feel weird about it also. I haven't figured it out. And maybe what we want is just a shorthand syntax for move.
Yeah,
That means capture only local variables.
Mm-hmm.
And then, which is sort of what you suggested already, but
Yeah.
I would tie it into a more general closure capture syntax, and it just has some
Yeah.
shorthand. And then all we do is every move closure, like no matter what, becomes that shorthand from now on.
Yes, exactly.
That would be a plausible route that I'm happy with.
Yes. Do we want to offer that shorthand syntax for non-move closures? Like if someone wants certain things to be just borrowed completely.
Yeah, I don't know.
Or, okay.
I mean, maybe. I feel like
completely.
we have yet to see an example. I would like to see more examples, like convincing.
Yeah, okay. I'll see if I can find some things. But yeah, all right.
It seems plausible to me that this just doesn't come up as much without move closers. But
yeah, fair point.
I mean, this is an interesting example because I actually don't think the move is necessary here.
Okay, actually, if we go back to the maybe I might have just copied this. So yeah, never mind. Yeah, I think I just copied this over. So it's probably not the different thing, but if you look at 29 again, we can confirm if
I mean, it might have
moved
had
there or not. Okay, no.
Had move in it, but I think it would compile without move.
Yeah, and
Actually,
same.
Probably test this, right? So this might sort of validate my hypothesis or something. That this won't come up without move. So does this compile? No, because of some use standard panic. Okay, so I think if I take this out, yeah. So maybe what I'm saying doesn't make sense, and maybe this is like, but I would not be happy if we changed every single closure to that new syntax. That's a little, I would want to be a little smarter than that. every single move closure I could live with because those are pretty uncommon. And
Well, I was going for every move. Well, everything that's moved goes into that syntax. Not everything that's in that goes there, if that makes sense.
yes, yes. So that we could
Oh.
plausibly do. If we had a syntax that was like,
Just a bracket.
I don't know what it
Or-
would look like.
Yeah. Yeah, actually, I guess that makes sense. Move without an empty list or just a list will move everything, and move like that.
Like
will
I could
only move
imagine
certain.
saying if you have a closure like this one that
Mhm,
captures exactly one thing,
mhm,
or everything it captures is by move,
mhm,
we could convert it to this syntax. That's
mhm.
probably relatively low impact. What I'm wondering about are cases where some things are by move and some things are not. Like you could make an example easily enough here.
Yeah.
Something like this would be a mix. And now we would need some syntax that's like, you know, I don't know.
Well, I was thinking more around just the things that are
I'm
like
imagining
if we just do move F, then it just like moves F, and everything else just automatically follows through, like whatever it would have done earlier.
so
Well,
yeah, we'll have to see. This is all.
yeah.
If I think the syntax how I imagine in my head is like this. If you do this, it moves all the local variables.
Hmm.
If you name something, you can't
Hmm.
capture anything outside of that list, and they're moved. If you write
Okay.
dot, then you can capture things, and we infer the kind of move.
Okay,
I
that
don't
makes
know
sense.
if that's. I don't know if I actually like that. It's just what's. I can imagine people are gonna push.
Hmm.
Let me. The one bit in my head is that I sometimes wish I could more easily declare the things I expect the closure to use
Hmm.
every once in a while.
Yeah.
And I might want to capture that use case, but
Yeah. All
I
right,
don't know.
that makes sense. Okay, I think we are about time. I need to head off soon, but yeah, this makes sense. I guess first priorities will still be to get the mutation and all the fixes and sort of small open PRs we have. Well, the PRs that we're working for diagnostics and stuff,
Mhm.
and then we start migrations. I don't know if we'll actually get to migrations before next week. I don't. Are you available next week?
Next week I'm around.
Okay, I'll try to kick some things off then, and yeah, discuss any quick follow-ups we have. All right, thank you.
See ya.